Hello everyone. Today I'm going to present image sequence analysis via gated recurrent units and attention for Trachomatous Trichiasis classification. My name is Juan Carlos Prieto, and my collaborators are Hina Shah, Casey Jones, Robert Chu, Hashiya Khanna, Jerusha Weaver, Rebecca Fleckiger, Scott McPherson, and Emily Garr. This research is being done in collaboration between the University of North Carolina at Chapel Hill and RTI International. This work is being presented at the Medical Images and Deep Learning Conference held in Lübeck. So what is the motivation of this work? Trachoma is the leading infection cause of blindness worldwide. And it is transmitted from person to person through ocular and nasal secretions or eye-seeking flies that carry the infection from one person to another. The repeated infections may cause the eyelids scarring, and it causes the eyelid to turn inward and the eyelashes to touch the globe of the eye. And this condition is called trachomatous trichiasis, or TT. If this condition is not corrected, the intern eyelashes may abrade the cornea, and this will lead to blindness. And the primary way to correct this condition is through surgery. The majority of individuals that suffer from this condition live in low and middle income countries where the access to health services is limited. And there are many surgical campaigns that are conducted in rural areas, and people from the community are asked to go home to home and try to identify the cases. And the community members, they receive a brief training on how to identify the condition. And they go home to home and they invite the persons to come to the upcoming surgical camp. And a recent study published by Green shows that 30% of TT positive community members are not identified by the case finders. And there are many reasons why this could be the case. It may be that they don't have the sufficient knowledge to determine whether the eyelashes are touching the globe or not, or there is no a good understanding maybe of the problem. So in this paper, what we want to propose is to close the gap between experts and non-experts in assessing the condition. And to the best of our knowledge, we are the first group that is proposing to close the gap via capturing by commercial phones and assessing the condition. So in this example, we have two images that have moderate TT, which show a few lashes touching the globe, whereas these ones are severe because there are multiple lashes touching the globe. The approach that we propose here, we're going to take these images and we're going to identify our region of interest with a unit segmentation network. And we segment the upper eyelid and the sclera and the cornea. And our region of interest will be the upper eyelid, where we're gonna fit a smooth polynomial curve and then extract crops around this line. And we're gonna generate this image sequence that then we are gonna analyze via our gated recurrent unit module. We have a step as a feature extraction, and we use pre-trained networks, for example, VG19, ResNet50, or MobileNet. So every frame is processed by our feature extraction and then analyzed by the recurrent neural network. Finally, we use attention modules that will assign a specific weight to each of the frames and give more importance to a certain frame than another one. Finally, this is fed to a fully connected layer, and we have our predictions for TT. So the data in this study was collected as part of the Maximizing Trachea Surgery Success Trial in Ethiopia, and the images are captured by commercial phones. And we have an expert grader that has manually labeled our regions. For the segmentation, we train using 805 images, and for the classification, we use 1,398 images. And we have a holdout test set that is not seen by any of the two networks of 308 images. So that's the number of images that we will use to test both of our approaches. And here, although as we can see here, the dice score for the upper eyelid is low, it is enough to produce better classification results than other approaches that we tested. Here is an example of how the image sequences look like that are analyzed by our gated recurrent unit and neural network. So the first three rows here are simply using known architectures, but using resampled images to 512. And the last three rows are the approach that we're proposing here, but using different networks for feature extraction. This image that we see here is the top frames selected by our attention modules, and as we can see, it selected frames that have trachomatous trichiasis. So in conclusion, we have an approach that analyzes the high-resolution images captured by commercial phones. We have tested different architectures. First, we tested by just simply resampling the images, but then we decided to focus only on the upper eyelid region using the full resolution images, the full resolution as possible, and we have much better results using this approach. Initial test showed that using ResNet 50, it's about 15 seconds running in the phone, so we will have a near real-time application for detection. Thank you very much, and I'm open for questions.